The math class, sorry, has also received quite a lot of new functions. It used to be only like a couple or three, I think, at the end of last quarter. Now it's grown in size. We have clamp values for both floats and vectors. We have projections onto vectors, which is used in some of our intersection tests, and we have intersection tests between every type of collision volume that we have within our engine. No matter what type of collision volume is set, we have a way to intersect, including B-spheres and points. Yeah. So moving into the Dragon math, I'm not going to get too much into the actual math behind all of this, since we've gone over it in class. But yeah, we can see that we have our between two ABBs, we just test returning false, and only if it goes through does it return true. We B-spheres and OBBs, we go into the world space of one, clamp it, using our fancy clamp function for vectors, and then we return whether it intersects with that and a point, or rather a vector. So we have that, and then we have our intersect for two OBBs, which is very disgusting. Took a lot of work to get right. Same for the AABB and OOBB, which is basically the same. It's almost a exact carbon copy. There are a few minor differences, which is why we can't have it be an exact copy, but it's almost identical. So those are the tests we have within our math functions. I know you say that every method should be no more than a few lines, but the OBBs are kind of the exception. To be fair, the only reason they're so long is because we have this massive initialization where we get all of the normals that we're going to be testing against, or rather the axes that we're going to test against. And then this is the only actual testing part of the function. So it looks like a lot, but the actual math part of it isn't too big. And then we just test for max projection, which is this function up here. So the functions themselves are all fairly short, it's just sometimes the initialization looks a little ugly. Alright, and that's all of the Dragon math for